So here's lesson 2 of Unit 6. So we're going to start off here with noticing and wondering. All right, so the text has a whole bunch of different things, but I'm just going to put a few things together here, okay, for you. All right, so in each diagram, two rectangles of different lengths okay, so that would be the first one. Another thing we could look at is we could say the yellow rectangle is the same length as the green and blue rectangles put together. Okay, so we can see that we have 1 and 1. Okay, so that's how we're getting that one right there. Okay. Another thing we could say is, let's see, the green rectangle looks like it is 3 times as long as the blue one. Okay, there's a whole bunch, but those are just some things that we could look at. Okay. So walking half as much again. Complete the table to show the total distance walked. Okay, in each case. All right. So the first one, Jada's pet turtle walked 10 feet and then half that length again. Okay, so we have 10. Then we're going to add half the length, so the total distance is going to be 15. Okay. The next one is, all right, so we have baby brother walk 3 feet and then half that length. Okay, so half of 3 is 1.5. So the total distance is 4.5. All right, Jada's hamster walked 4.5 feet and then half that length again. Okay, so 4.5 divided by 2, 2.25. Okay, so this is going to be 6.75. Jada's robot walked for 1 foot and then half that length again. Okay, so plus half a foot is 1.5 feet. a person walked X feet, and then half that length again. Okay, so the person walked a certain amount of feet, okay, and then they walked half of that distance. So if our distance is X, okay, we have X, which is our initial distance that is walked. Then we're going to add 1/2 of X. Okay, we have to add those two together. Okay, so this is the same thing that we basically did here, but now we're just looking at variables. Okay, so we have X plus 1/2 of whatever that is. Okay, so if you put these numbers in, okay, you would get these answers. Okay, so how did we get the distance for each of the case? Okay, is we take half of the initial distance and then added it to the initial distance. Okay, so we took half of the initial distance and then we added that to the initial distance. Okay, all right. Number 3, let's see, 2 students each wrote on, sorry, I'm just trying to get to, all right, sorry about that. 2 students each wrote an equation to represent the relationship between the initial distance walked and the total distance walked. Okay, so May wrote y equals x plus 1/2 x. Okay, and then Kieran wrote y equals 3/2 x. Do you agree with either of them? Okay, so we can agree with May. Okay, but what about this one? Okay, so basically, if we look at y equals 3/2 x, okay, then what we're going to do is we can turn it into a mixed number, y equals 1, okay, and 1/2, right? And so basically what I did is I just turned this into a mixed number. And then, so this right here, okay, is basically this because we're multiplying it by 1, okay? And then we're going to have our fraction, okay? So 1/2 is the same thing as 3/2. Okay, so then what we're going to do is multiply that by x. Okay, so if we have Kieran, we can take every number and Okay, so something I'm going to use a lot is plug it in or substitute and get the other entry in the table. So basically, what I'm doing here, see if I can move this over. I can't really. All right, so here we have y is equal to 1.5 times x. Okay, so y for our first one is going to equal 1.5, okay, times 10. And when we do that, we're going to get 15. So you can plug each of these numbers, okay, into our equation where this is x and this is y, okay, to get this equation or to double check the equation and make sure that we are correct. Okay. Next one, we have, are you ready for more? Okay, so Zeno jumped 8 meters. Then he jumped half as far again. Then he jumped half as far again. So after 3 jumps, he was 8 plus 4 plus 2 equals 14 meters from his starting place. Okay, so Zeno kept jumping half as far again. How far would he be after 4 jumps? 5 jumps and 6 jumps. Okay, so let's go ahead and do that. We know that we have 3 jumps. Okay, he's going to be 14 meters. Okay, so to get to 15 meters, okay, that's going to be our 4th jump. Okay, so let's just go ahead and do it the long way. Okay, plus, for our 4th jump, okay, it's going to be 12, 13, 14, 15. For our 5th jump, okay, we're going to have 8 plus 4 plus 2 plus 1 plus half of 1. Okay, so that's going to be 15.5. And then after the 6th jump, we'll have 8 plus 4 plus 2 plus 1 plus 0.5. Okay, half of that is going to be plus 0.25. Okay, so this is going to be 15.75. Okay, we can also write this, it's also equal to 15 and 3/4. Okay, so before starting jumping, Zeno put a mark on the floor that was exactly 16 meters, okay, from his starting place. How close can Zeno get to the mark if he keeps jumping half as far? Okay, so basically he can get as close to 0 as he wants. Okay, eventually, okay, it's going to be such a small jump he won't be able to do it. Okay, but in theory, he can get as close to 0 as he wants by dividing the number by 2. Okay, and that's what we saw up here. This is what we did up here. Okay. Now, if you enjoyed thinking about this problem, consider researching Zeno's paradox. Okay. Hey, you can do this if you want, but you don't have to. Okay. For the card sort, we're going to go ahead and cross that off. Okay, and then we've got these 3 questions here. All right, so let's take a look at this. Match each situation with a diagram. A diagram may not have a match. Okay, so it might not have a match. Okay, so we have A, B, C, and D. Okay, and then we have our information down here that we have to match up. All right, so for the first one, okay, we have Han slept for X hours, and then May slept 1/5 of that. Okay, so we could say that Y is May. Sorry. Uh, let's see. Yes. So this is going to be. Oh, I see what I need to do. All right. So here we're going to have 1/5 of May. Okay. So if we look at this, we can see that our X, okay, or Han, okay, is X hours. Okay, May slept 1/5 less than that. Okay, so now, is this 1/5 less than? No, this is 1/5 less than. Okay, so the first one is going to be C. Okay, so May biked X miles. Han biked 4/5 more than that. Okay, so we have our X, right? Our X's are on the top. I'm going to go ahead and erase this so we don't get it mixed up with the other problems. Okay. So here we've got, we need to look at our X, okay, and then we have to add 4/5 more. Okay. So this right here is my X. I have 1, 2, 3, 4, 5. Okay. But then I also see that I have these boxes right here. Okay. And so this right here we're looking at our y from here to here, that is going to be 4/5. Okay, so this is 1/5 less than. This is 4/5 more than. Okay, and then Han bought X pounds of books. Okay, so remember we're looking at the top. Okay, X pounds of books. May bought 4/5 of that. Okay, and so this one, okay, is going to be, if we have X, okay, and then we have 1, 2, 3, 4, 5. So this whole thing is 5/5. Okay, and then May bought 4/5 of that. Okay, so this is 1, 2, 3, 4. So this is my 4/5 of the total number X here. Okay, so this is C and this is B. All right, so the next one is, for each diagram, write an equation that represents the relationship between X and Y. All right, so here we're going to say that Y, okay, is our dependent variable. Okay, and X is going to be our independent variable. Okay, that's usually how it works. Okay, so I need to know if I have Y, okay, remember it's going to depend on X. So how much more is Y than X? Okay, so what we're doing is we're looking at this. Okay, how much more? Okay, it's going to be this right here. X is 1, 2, 3, 4, 5, 6. Okay, so, but we don't have 6, right? We only have 5/6. But Y, right, is going to be the dependent variable. All right, so what I need to do is I'm going to be looking back, okay, at what we looked at earlier in one of our tables, where I can say that Y is equal to 6/5 of X. Okay, so this is 1, 2, 3, 4, 5/5. Yeah, let me change this. We're looking at it a different way. I apologize. Okay, so this is 1, 2, 3, 4, 5. And so now what I'm going to do is I'm going to add that one more piece. Okay, so that's going to give me the 6/5 because this is bigger, okay, than this. All right, so that is going to be our equation. Y is equal to 1, okay, this is also equal to Y equals 1 and 1/5 X if we turn it into a mixed number. Okay, so here's my 1. Okay, and then this part right here is 1/5. Right, so B, I'm going to go ahead and erase this. You don't have to. Okay, but I just want to be able to show you how we're getting our numbers. I'm trying to erase something that's already there. Okay, so here I'm going to have 1, 2, 3, 4, 5. Okay, so this is 5. So each one of these, right, is going to be 1/5. Okay, so this whole thing here is 5/5. Okay, but now I'm adding some more fifths. Okay, so this right here would be 6/5. This would be 7/5, 8/5, 9/5. Okay, so what we can say here is that y is equal to 9/5 of x. Okay, because we have, it's basically 1 and 4/5. If I change this, okay, it'll be 1 and 4/5. Okay, and that's what I have. I have 1/5, 2/5, 3/5, 4/5. Okay, so either one of those will work. Oh, let me put it down here. Equals blah, 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 blah. C. Okay, so now I have my x and my y. Okay, so now y is less than my x, right? So it's going to be less than 1. Okay, so y, okay, is how many fifths, okay, of 5/5. Well, we can see it right here. We have 1, 2, 3, 4/5. Okay, so y is equal to 4/5 of x. Okay, so remember this right here would be 1/5, but it's not on the orange. Okay, so y is only 4/5 of x, and x is 5/5. Okay. So here, the last one, y is equal to, all right, so I have my x, right? This is 5/5. So this right here is 1/5 of x. So y is equal to 1/5 of x. All right. For number 3, we're going to go ahead and skip that. Okay, and then we have this problem right here. Okay, now let's see. Something that is important is the distributive property. Okay, so that's giving us a shortcut for calculating the final amount. Okay, so basically right here, okay, is going to be our distributive property. Okay, and so what I can do is I can factor out a 4, okay, because it's going to be in each one of those terms, and then I can multiply it by 1 plus a half. Okay? So we're going to be looking at more of this a little bit later. Okay, that's it for this lesson.